Good morning, everyone. So since I'm not here today at school, I'm going to use the screencast to go over the homework so that you can hear me talk through all of the steps to make sure that you understand what we're doing and to make sure that your work is correct. So make sure that you get a red pen and you just pretend like I'm standing up there at the front of the room and put red check marks when you're supposed to put red check marks, correct things that you need to correct. Let's start with page 67, number 46. A 2.5 gram sample of a hydrate of barium chloride is heated, and 2.15 grams of the anhydrous salt remained. What is the percent water in the hydrate? So just like we did on Thursday, you were after percent water. So your formula needs to be percent water equals, remember, this is part over whole. So you need grams of water over grams of hydrate times 100. And then when you go back and look at the problem, they tell you 2.5 grams of a hydrate. So that goes in the bottom, but they don't tell you how much water. So that's the one that you have to solve for by doing the hydrate minus the anhydrous. Oh, and then you only need one decimal place, so you should be using that for the water. Remember, there's one decimal place in this number, there's two decimal places in this number, so only one decimal place in that answer. So 0.4, so then you just plug that into your calculator, and you need 1 sig fig, so, multiplied by 100. So you're going to get 20%. All right, let's move on to number 47. Same idea. We still need percent water. So, you need percent water. So you're going to do grams of water over grams of hydrate times 100. So then grams of hydrate is 5.0. Grams of water, you're going to do 5 grams of the hydrate minus 3.4 grams of the anhydrous. So that's going to be 1.6 grams of the water. You're going to plug that into your calculator. 2 sig figs, you are going to get 32%. Okay, and then we moved on to 48. This one's a little bit different because you have to find the value of N. So this is the one up at the top of the page. You should have 5 steps that you wrote down in class the other day. So you are going to take 3.9 grams of the anhydrous salt, which is this, and you've got to convert that to moles. So you are going to put the molar mass from the periodic table here. So that's 1 mole of copper nitrate. And then when you plug all that into the one copper plus 2 nitrogens plus 6 oxygens gets you this, and you get 0.021 moles of copper 2 nitrate. And then you got to figure out water, but they tell you the hydrate, and then they tell you how much anhydrous. So you know that 5.0 grams of the hydrate minus 3.9 grams of the anhydrous gets you 1.1 gram of water, and you're going to take that and convert to moles. So when you convert to moles, you get 0.021 moles of copper 2 nitrate and get 0.061 moles of water, and then you're going to divide by the smallest, and you're going to do that to both of them. And then you will get, this is going to be, this is going to be 1.0. This is going to be 2.9, which will round to 3, which will round to 1. So then your formula that you're going to write is this. Because remember, these numbers that we just rounded to are our coefficients. And then the problem says, what is the value of N? That is your value of N. All right, analysis of a compound shows it to be 43.6% phosphorus and 56.3% oxygen. Determine the empirical formula. So your first step is to convert everything to moles, and so you should get 3 sig figs here and 4 sig figs here. And then after that, you divide by the smallest. So that'll give you 1.00 here, and this gets you 2.50 here. So you're going to have to multiply that by 2. So then you have to multiply that by 2. So then that will be roundable to 2, and that will be roundable to 5. And so then this is your answer. And I actually think that's from your quiz that you just got back. All right, here's your next one. Mylarin is a useful anti-cancer agent with a very short duration of action. Calculate percent sulfur in this drug. And they give you that crazy structure in your book. So you have to find the molar mass first, and you would get that number. And then when you're trying to find percent sulfur, remember it's grams of sulfur over grams of mylarin times 100. And then you just pick the numbers that you need from up there. So 278.24 for that, and then 64.12 for that, because you need both of those sulfurs that we had. Times 100, we need 4 sig figs, so you should have gotten 23.04%. Okay, and then this one is a little bit of a review because we've done moles to grams before, but we've not ever done it when you had a compound. So now we have a compound. It is the same exact process as before. So you write down the number that you're given. You want to get, remember, if you want to put that over 1, you can. You're going to get rid of these units. You're going to get these units. This should look familiar. That's molar mass. So you need to be looking at the periodic table. This is probably a number that you're learning. It's 18.01 grams in a mole for water. So then you just plug that into your calculator. You need 3 sig figs. That's 108 grams of water. All right, so then let's work a couple extra ones just for practice. So get out your pencil and let's work these together. Okay, so let's look at page 61, number 2. A student weighed out 7.5 grams of a hydrate and heated it until 2.77 grams of anhydrous salt remained. Find the value of N. So again, remember, up at the top of the page, you have 5 steps that we wrote down. So your first step is to take the grams of anhydrate and convert that to moles. So you should be taking 2.77 grams of the anhydrate and convert it to moles. And so you get that number off the periodic table. That's molar mass. And then when you divide that out, you get that number of moles. All right, and then you got to do the moles. Okay, so that's step 1. Step 2 says grams of water to moles of water. They don't give that to you, so you've got to find that. So you're going to do grams of the hydrate minus the grams of anhydrous that they gave you to figure out that you have 4.73 grams of water. You really should only have 1 decimal place because of this number. So 4.7 grams of water, and then now we've got to convert that to moles. So 18.01 grams of water is a mole of water, and then you're going to plug that into your calculator, and you get 0.263 moles of water. All right, step 3 says divide by the smallest. So in that case, it's 0.0261. So divide both of them by 0.0261. This one obviously gets you 1.00. This one gets you 10.1. Those are all roundable, so that's going to round to 10. Oops. That's going to round to 1. And remember, these are your coefficients. So you are going to have Na2CO3 and one of those, and then 10 waters. And so they're asking you to find the value of N. 10 is your value of N. Okay, so then let's look at page 66, number 45. A compound is 54.5% carbon, 9.1% hydrogen, and 36.4% oxygen. Its molecular mass is 88.0 grams per mole, what is the molecular formula? Okay, so remember, these start off as finding the empirical first. So you need to take all of those percents, convert to grams, convert to moles. So if you find the number of moles of each one of those, these are the numbers that you should get watching sig figs. And then you're going to go through and divide by the smallest number of moles. And when you get those numbers, lucky for us, all of these are roundable numbers. So that's going to round to 2, that's going to round to 4, and that's going to round to 1. So C2H4O. And remember, this is called your empirical formula. You're not done yet, though. So after you find the empirical formula, you have to find the mass, the molar mass of this thing. And so you use all of that to find the molar mass, which I find to be 44.05, and you compare that to the number that they gave you. They say that the molar mass, the molecular mass, is 88.0 grams per mole. And so you take that and you divide that by the number that you just got. And you get 2.00. And so remember, that means that you multiply all of these coefficients by that number. So you'll have C4H8O2, and this is the molecular formula, which is the answer to your question. Okay, so for the next few problems, when you click on it, try to work them first and pause this video, and then when you're done, play it so that you can see that you did it correctly, and then make corrections about what you need to correct if you did anything wrong. Okay, so for 59, page 59, number 2, you had to find the molecular formula of saccharin. So when you're solving this, you take the percents and go to grams, and then you're going to take the grams and go to moles. And so if you're watching sig figs, those are the values of moles that you should get, and then you're going to divide through by the smallest. So then you get those numbers, which will be your subscripts, so C7H5O3SN. And the order that you put those in, not that important to me. So then the next thing you have to do is you have to find the molar mass of that. So if you look at the top, I found the molar mass of saccharin, which comes out to be 183.16 grams. And that actually matches the number that they gave me in the problem, 183.18 grams per mole. And so this formula down here is both the empirical and the molecular formula. They are the same thing. All right, then let's do 61, number 2. So remember, pause this, then work it, and then turn this back on and see if you got it correct. So you should take the number of grams of the anhydrous salt that they gave you, convert that to moles using the molar mass off the periodic table. And so then you take the number of grams of the hydrate minus the anhydrate, so you get 4.7 grams of water. You should only have one decimal place because the number of decimal places in hydrate is 1, and then you're subtracting. So then you take the number of grams and convert that to the number of moles of water, and you get that. And then you are going to go through and you are going to divide by the smallest, which in this case is 0.0261. So then that'll be 1.00. This will be really close to 10. 9.9, oh, actually 10 with a decimal point after it. So then that obviously rounds to 10. That obviously rounds to 1. So then when you write your formula, you write the anhydrate part times, and then you're using this 10 from here, and then that's how many waters you have. So this is the formula of the hydrate. If it's asking for the value of N is 10. Okay, so then let's try page 61, number 3, which is exactly the same kind of problem, just with a different hydrate. This is actually the hydrate that you used in lab. So your first step is to take the grams of the anhydrate, which they're calling the residue here, residue meaning what's left in the crucible after you heat it, and you're going to take that and convert to moles. So you have to find the molar mass of copper sulfate, put that in the bottom of your fraction, and then solve for moles, 3 sig figs. Then you're going to take the grams of the hydrate minus the grams of the anhydrate to figure out how much water you have. And then you get 0.24 moles of water. and then you're going to divide through by the smallest, which in this case is 0.0201. So then when you divide through by the smallest, you get a 1 to 12 ratio, and so then you're just going to put it all together. So you have copper sulfate, and that would have a 1 in front of it because of that 1 right there, dot 12 waters, and that is the formula of your hydrate. It's asking what N is 12. Okay, so that was a whole bunch of practice problems. You should have all of those worked in your book, checked, red check marks, all of that stuff that you know is the normal expectation that I would have during class. You do have a quiz tomorrow. Check the website for details. To study, I would rework problems. You should have plenty of them in your book to work where you have correct steps and units and sig figs so that you can double check what you are doing as you practice. Good luck. Happy Thanksgiving. See you guys when we get back from the break.